Good morning, students. Welcome to today's discussion on operation research. We'll be talking about the first module, wherein we've got two topics. One is the formulation of a linear programming models, and the other one is the solution for linear programming models by graphical methods. So now today's discussion we will be seeing the topic, that is the formulation of linear programming models. So basically any formulation for that matter involves three main stages. One is the identifying the decision variables, the second one is identifying the objective function, and then identifying the constraints or the restrictions to which that particular problem or situation is subjected to. So the summation of all this, that is the decision variable, objective function, and the constraints, once we have this, we can write the linear programming model, so wherein which will consist of the objective function and the constraints. So let's have a look into the problem. The problem statement reads, old ends can be bought at rupees 250 each and young ends can be bought at rupees 500 each. The old hens lay 3 eggs per week and young hens lay 5 per week. Each egg cost rupees 10 and a hen cost rupees 20 per week to feed. If a person has only 20,000 to spend for hens, formulate the problem to decide how many of each kind of hens should be buy, and you cannot house more than 40 hens. Formulate the problem as LPP model. So that's like a real life situation wherein a person is having 20,000 rupees and he has some space, so wherein he can house 40 hens. So for him, so what we have to suggest, we have to formulate a linear programming model such that it can be benefited from that. So since it's about bringing the hens and which lays eggs, and by selling each eggs is getting a profit of 10 rupees, and in the meanwhile each hen is taking 20 rupees per week for feeding. So feeding expenses is 20 per week with respect to each hen. So with all this, we have to write the linear programming model. So before writing the linear programming model, so let's go step by step. So the first thing when you are formulating a LP model is to identify the decision variables. So that means which are the variables that controls the outcome of that particular situation. So there are two things which control the situation here. One is the old ends, the other one is the young ends. That means his profit depends on how many old ends he has and how many young ends he has. So that means here in this problem, the decision variables are the number of old ends and number of young ends. So let us denote the decision variable x1, which indicates the number of old ends. Similarly, let x2 be the number of young ends. Number of young hens. So that's the first thing, to identify how many variables are there. So which means what are all the parameters that particular situation is dependent upon. So here the profit depends on how many hens he has. So how many old hens and how many young hens. So coming to the construction of the objective function, before we write the objective function, we should first identify its profit. So here the profit is not straightforward, it is not just a profit which is 10 rupees per egg. So there is also an expense of 20 rupees per week with respect to each hen. So first let us see what is income. So income per week. So if I say income per week, so income depends on number of eggs for that matter, so obviously, and it also depends on number of young hens and number of old hens. So young one will lay 3 eggs per week, sorry, the old one will lay 3 eggs per week, and the young ones will lay 5 per week. So the old ones, or the old hens, will lay 3 eggs per week. 3 eggs per week. So we are calculating the income per week. So the old hens will lay 3 eggs per week, multiply by how many old hens he has, and multiply by the income per egg. So income per egg is 10 rupees. The x1 represents the number of old hens, and 3 eggs is what it lays for 1 week. So that is with respect to old hens. If he has, in addition to that, if he has young hens, so they lay 5 eggs per week, and x2 is the number of young hens. So 5 times. So 5 is the number of eggs that the young hens lay per week, and x2 is the number of young hens that he is going to purchase, and multiplied by the cost of each egg, so it is 10 rupees. So his income per week is, so 3 times 10, that is 30x1 plus 50x2. So if there was no expense term, so then directly that would have been the objective function 30x1 plus 50x2. But since expense is there, that got to be subtracted. So the feeding cost, so the feed cost per week is 20 rupees. A n costs 20 per week. So each n will cost 20 rupees per week. So 20 rupees multiplied by the number of old hens, 20 rupees multiplied by the number of young hens. So that is the feeding cost per week. So therefore his profit will be, so therefore the profit will be income per week minus the feed cost per week. So that is like, if I call that as equation 1, and that as equation 2 is total profit per week, is total profit per week will be equation 1 minus equation 2. So that is 30x1 minus 20x1. So that will be 10x1. 50x2 minus 20x2, that is 30x2. So that is the objective function. So now the objective function is maximize z. So the objective function is always represented by that letter z, and that represents the objective. If it is a profit, we'll refer it as maximization case, that is maximize z. If it is about minimizing the losses, then it becomes minimize z and whatever the objective function. So that means it represents the outcome of that particular situation. So 10x1. So 10 will be the profit that you get by each old n multiplied by the number of old n's. Similarly, 30 times x2. So where x2 represents the number of young n. So from every young n per week, you will get a profit of 30 rupees. So that's the objective function. Now coming to the constraints, or what are all the restrictions. We got to formulate, we got to know what is the profit that is going to get out of this situation. Now we got to identify what are the constraints. There are 2 constraints here. One is the budgetary constraint, the budget constraint he has, and then he has one more constraint, that is with respect to, and he cannot house more than 40 hens. So there is a space constraint as well. So he has a space restrictions. It's not only the budget, he also has a space only which can accommodate 40 hens. So coming to the budgetary constraint, so what is the total, the maximum amount that he can spend? So he can spend only 20,000 rupees. That means how many ever the hens that he can buy, but the total cost of that should be less than or equal to 20,000. You cannot spend more than 20,000. The meaning of that, the total expense should be less than or equal to 20,000 rupees. So coming to the budgetary constraint, how can we write? The number of old hens multiplied by the cost of each old hen, that is 250 x1 plus x2 represents the number of young hens multiplied by the cost of each young hen, that is 500. So that is 500 x2. So 250 x1 plus 500 x2 must be less than or equal to 20,000. So the meaning, physical meaning of that, the number of old hens multiplied by the cost of each one, that is 250 rupees is the cost of each old hen. Similarly, the number of young hens multiplied by the cost of each, that is 500 rupees. So put together, the cost should not exceed 20,000. So that is the first restriction. Then coming to the second one, he has a space constraint, so which tells that he cannot house more than 40 hens. So put together the number of old hens plus the number of young hens, that is x1 plus x2 should not exceed 40. You can house only 40 hens, and hence that constraint is nothing but the total number of old hens plus the total number of young hens should not exceed 40. So that is a space constraint. And one more constraint which is common for all the linear programming problems is the non-negative constraint. So which means x1 should be greater than or equal to 0 and x2 must be greater than or equal to 0. So here we have two variables. So that tells both the variables should be a positive number. So it cannot be a negative number. You should not get x1 as minus 5 or minus 10. That will not give any physical meaning. Either you can go, if I say x1 is 0, you can buy all 40 old hens, or if I say x2 is 0, you can buy all 40, depending on the budgetary constraint. You can buy all, you can either go only with the old hens, either you can go only with the young hens, or you can go with the permutation and combination, but there cannot be any negative number. So that's the meaning of non-negative constraint. So those are the three major steps for any formulation problem for that matter. The first thing is you got to identify the decision variables, so which are the factors that control the problem, and then you got to formulate the objective function. If it involves profit, so it's a maximization case. If it is about minimizing the losses, it's the case of a minimization problem. The objective function is represented by the letter Z. And if it involves only profit, so directly that will be our objective function. Z is maximize Z equals to 30x1 plus 50x2. But in this case, there is some expenditure, and hence that expenditure got to be subtracted from the income. So income is given by 30x1 plus 50x2 minus the feeding cost is 20x1 plus 20x2. The subtraction of those two equations will give us the objective function. So once the objective function is formulated, we got to identify the constraints. So here there are only two constraints. One is with respect to the budget. So put together, you can spend only 20,000 rupees for procuring the hens. So wherein the cost of each hens has been given here. So the cost of each multiplied by the number of hens that is going to procure will give us the budgetary constraint. So coming to the space constraint, you can accommodate maximum 40 hens, and hence put together that should not exceed the number, the value of x1 plus x2. That can be 20 plus 20, that can be 10 plus 30, that can be 5 plus 25, that can be 25 plus 5. Any permutation and combination, or even it can be 0 plus 40 or 40 plus 0, anything for that matter, that should be less than 40. It cannot be 5 plus 35, or it cannot be 5 plus 40, so which is 45. So then that means the solution is wrong. So that's the constraint to which this objective function is subjected. So after writing all that, so you can just write the LP model. So LP model is basically, you should only constitute, or it should contain only that mathematical term. So that is maximize Z or Z max. So however you want to write, you can write it is 10x1 plus 30x2 subjected to constraints. In simple, we'll write it as STC, subjected to constraints. 250 x1 plus 500 x2 is less than or equal to 20,000, and then x1 plus x2 is less than or equal to 40, and then x1 is greater than or equal to 0 and x2 is greater than or equal to 0. So that's the LP model. So linear programming model is that one. So that can be found. So the solution of that x1 and x2 can be found by using graphical method or any other method, which will be taking up in the subsequent discussions. So once you have the mathematical model, there are a variety of the methods available to find the value of x1 and x2. So here in this particular topic, we are dealing only with respect to how to convert the real life situation into a mathematical model, that is a linear programming model. So that's the LPP for this given problem. If you got any doubts about that, you can take up in the discussion class. Thank you.